Hello students, in this video we'll see an example of approximating a probability using the Central Limit Theorem. Let's suppose that a box contains 100 books that each weigh Wi for I between 1 and 100, where Wi where W1 through W100 are independent, random variables, identically distributed. With mean 1, so you can say 1 pound, for example, 1 pound, and standard deviation .05. Let's find the probability that the weight, total weight, is more than, of the box, $100.75 pounds. So for this problem, what we'll do is we'll note that the total weight is equal to the sum of the weights, so weight 1 plus weight 2 plus weight n. And therefore what we're after is we're after the probability that W1 plus W2 plus W100 is bigger than 100.75. And now what we'll do is we'll recall what the Central Limit Theorem states. The Central Limit Theorem states that x1 plus xn minus n times mu over the square root of n sigma converges to a normal 0, 1 distribution as n gets large. That's our Central Limit Theorem. And the assumptions of the Central Limit are that x1 through xn is an IID sequence. Mu is the common mean, sigma is the common standard deviation. So what we'll do is we'll standardize this. What we'll do is I'll subtract off n times the mean. So n in this problem is 100, and the mean is 1. So I will subtract off from our probability W1 plus W100 minus 100 times 1 from the inequality, W100.75 minus 100. So it doesn't change the probability at all. And over here, we'll see that this will just be 0.75. And then what we'll do is we will divide by the square root of n times the standard deviation. So what we'll do next is we'll say this is equal to the probability that W1 plus W100 minus 100, then I'll divide by the square root of 100 times 0.05 is bigger than 0.75 over the square root of 100 times 0.05. And what we'll have over here, and now we can say that this random variable over here has an approximate normal 0, 1 distribution by the Central Limit Theorem, since 100 is a large value of n. And so we'll call this random variable over here z. And so what we have over here is we have the probability that z is larger than 0.75 divided by, well, this is 10. 10 times 0.05 is a 0.5. And we can simplify this. This 0.75 is 3/4, and I'll multiply 3/4 by 2. And if we do so, we'll get 3/2. So this is the probability that z is bigger than 1.5. And this will be equal to 1 minus the cumulative distribution function of a normal random variable. So this is the CDF of a normal random variable with mean 0 and variance 1 of 1.5. And we can look this up in the table and compute this as the probability that the weight, the total weight of the box, exceeds 100.75. Thank you very much.